Hello and welcome to FSC iCalc's tutorial on hydraulic graph calculations. This applet is designed for displaying water supply curves and system demand curves in the semi-exponential graph as required by NFPA 13. It's useful for hydraulic calculation submittals, visualizing your water supply versus your system demand, and checking to see how changes in the water supply may affect your system. You'll need a flow test in order to use this app correctly. The first thing we want to do is open up our hydraulic graph page on iCalc. You'll need to have a pro account in order to use hydraulic graph. If you don't have one right now, that's okay. You can get one for a month for free without entering your card information when you sign up. Go ahead and do that now if you haven't, and meet me back here. Alright, so today we're going to work through three different situations: city supply only, pump only, and city plus pump. Each of these supply situations has a few different things to consider. So let's start with city supply only, as it's the simplest. So you can do this by selecting no pump from the supply situation. We will enter in two main sets of data here: our supply information and our demand information. Starting under the system information inputs, we will enter in that we need 52 psi at 1000 GPM. From there, we'll add that our highest sprinkler is 32 feet up and that we require a 10% safety margin in our calculations. Lastly, we can add our hose demand. Let's put that at 250 gallons per minute. Alright, next we'll enter in the supply information that we have gathered from a flow test. You will need to have a previously gathered flow test and have an applet. We have an applet that helps you do that, along with a video explaining it. Referencing my flow test that I gathered earlier, I enter in the static pressure of 64 psi, residual pressure of 52 psi, and the hydrant flow at 957 gallons per minute. Those are all the inputs we need, so let's hit process data and see what we get here. Looks like we don't have enough pressure from the city to supply our system. The graph shows the demand line with a horizontal red line for hose demand. The dashed light blue line is your safety factor, which we can see here is negative as it comes down from the red line. Reading the output, it shows that we are shy of safety pressure by 7.67 psi. You can read it prints a warning as the safety factor is below our required safety factor we input earlier. So in this situation, we're probably going to need a pump. Let's look into adding a pump by doing a hydraulic calculation for city and pump. Afterwards, we'll look at just the pump situation. Alright, so go back to your pump type dropdown and select supply and pump. And let's leave our system information and our city supply alone. Scroll down to pump information and you can see your variables for the pump. You'll see a lot of input boxes, but don't worry, we only really need to enter in 2 points. By entering in what the rated flow and rated pressure are, the input boxes will automatically fill to the standard pump pressure points. That's 1.2 times rated pressure at static and 0.65 times pressure at 1.5 times rated flow. These input boxes are here in case you need to custom enter your own exact pump points, perhaps from a pump test report. I'll enter in 1000 GPM for rated flow and 50 psi for rated pressure. Then I'll hit process data again. You can see that we've added 2 lines to the graph, the pump curve and the combined supply line. This combined supply line is how much water we will have available in total. As you can see, adding this pump helped our situation, as we now have a safety factor of 39%, well above the required 10% we entered in earlier. So let's look at supporting this system with only the pump, no city supply. Scroll back up and select pump only from pump type. You can see this removed our inputs for city supply. The inputs for pump remain the same as before, so let's just use our old numbers and see if this pump is big enough on its own. Hitting process data, we can see it's clearly not. Our safety factor is negative 23%, clearly not an adequate supply. We would need a bigger pump in this situation or a better supply. Alright. That's all for today's tutorial. I hope you found this video helpful. If you still have any questions, you can reach us by going to the contact page on iCalc website or by emailing support@fscinc.com, and I'll leave those links in the description. Thanks for watching. Make sure to subscribe and check out our other videos.